In this video, we're going to start to look at how to prove triangle congruence. But looking back for a second, you may recall that for this triangle and this triangle to be congruent to each other, they have to have 3 pairs of congruent sides. So 1 pair there, 1 pair there, and 1 pair here. Oops, well, that's supposed to be 3 little hash marks, not a million. All right, and it also has to have 3 pairs of congruent angles. So this could be congruent to this. Here could be congruent to this here, and 1, 2, 3, this could be congruent to this. So that would be a congruent triangle because it has 3 pairs of corresponding congruent sides and 3 pairs of corresponding congruent angles. Now, the great thing when we're checking for congruence and going to prove congruence, we don't actually have to check all 3 sides and all 3 angles. It's actually enough to check just 3 things. Now, the 3 things could be that we're checking that the sides of one triangle are congruent to the sides of another, or we could check that the side angle side, which means 2 sides and the angle in between, so 2 adjacent sides and the angle in between, we could check for congruence there. So if we have side angle side being congruent and corresponding to side angle side, then that would prove full congruence as well. We have a couple more ways we can test for congruence of a triangle. We could check for adjacent angles and the side in between. So that would tell us congruence as well. And one more way, we could check that 2 angles next to each other and then the side beside it are congruent, so AAS. So these are all ways that we can check for congruence. There are a couple ways that we cannot check for congruence. We cannot check for congruence, so this is a no-no here in this corner. If all angles are congruent to each other, that doesn't mean that the triangles will be congruent to each other. It just means that they will be similar. They will be similar, but they could be much bigger or smaller than each other. And also, this one is easy to remember because it's not a cool word. It's not a word we want to say. That does not prove congruence at all. So these are no-nos. That's not what we're going to check for. All right, so in this video, we're going to do one proof. And in the proof that we'll do is a side proof. So we want to check if all 3 sides of this example are congruent to each other. And we're going to do a 2-column proof in order to do this. Okay, so now I think we're ready to look at our 2-column proof. Now, a 2-column proof is just a list of things that lead to this conclusion here. They want us to prove that this triangle, GHL, on the left side, is congruent to this triangle. So we're going to just state our reasoning of why this triangle and this triangle are congruent. And in a 2-column proof, you really have to go through every single detail and back it up with reasons, definitions, and theorems and postulates that you've been learning. So let's go ahead and create a 2-column proof table. So we need, first of all, a statement. So we're going to make a list of statements, and then we're going to back our statements up with a reason. Now, I don't know why I made that so long, not necessary, but that's okay. All right. So the first thing in a 2-column proof, you always want to start off with your givens. So that was given, and this is given, and something else is given. So a bunch of stuff is given. All right, so given, first of all, GH, segment GH, is congruent to segment KJ. So that's given that GH and KJ are congruent to each other, and we can write that down because it's given. All right, so that's our reason there. So now, what else is given is that HL, segment HL and segment JL are also congruent, so we can write that down. So HL and JL are congruent to each other, and so we could write that down again because it's given. So let's see, that is HL, which is right here, and it's JL. All right, so we're getting pretty close to being able to prove this triangle is congruent. We just need a third side, because remember we're doing a side, side, side proof. So we are also given that L is the midpoint of GK. So this point here is the midpoint of GK. And because of the midpoint theorem, we know that, well, if L is the midpoint of GK, that must mean that GL and LK are also congruent to each other. So that's our next statement that we can write. GL segment is congruent to LK segment. And the reason for that is because of the midpoint theorem. So this is the reason why it's really, really important to keep track of all the definitions and all the theorems that you've been learning. Because these definitions, theorems, postulates will be the things that allow you to make these nice, bold statements and back them up. Okay. So finally, since we now have 3 sides that are congruent to each other, we can now boldly state, according to our side, side, side theorem, that all of our sides, that our triangle is actually congruent to each other. So triangle GHL is congruent to triangle KJL. And that's because we have 3 sides that are congruent to each other, and that is sufficient to prove congruence in triangles.